Okay, in this video we're going to look at section 8.2, and that is the law of cosines. If we think about a couple conditions here, if we had this triangle, and let's say we knew this side was 5, and this was 4, and this was 6, there'd be no way to set up a law of sines to solve. Remember, with law of sines we need at least one side and an angle across from it. So we have this side A, but not the angle across from it. We have angle, or we don't have angle B, but we do have the side across from it. And we have side C, but not the angle across from it. So we could not set up the law of sines. And let's say even farther here, let's say we knew these two sides, and maybe this angle between them was 30. But that was all we knew. So here we have side, angle, side. Again, we could not set up the law of sines. We have an angle, but not the side across from it. We have two sides, but not the angle across from either. So we could not set up a law of sines proportion. So we are going to need a different law, and that's going to be this law of cosines for the SSS or the SAS condition. And of course we can use the law of cosines to model real-life problems. That'll be in the second video. And we'll also look at Heron's area formula for the area of a triangle. That will be the third video. But let's check out this law of cosines. Two cases remain in the list of conditions needed to solve an oblique triangle, SSS and SAS. And if we look at either of these setups, we don't have any of the ratios for the law of sines. So here we have the standard form on the left, and we have the alternate form on the right. If we took this standard form and solved for the cos of A, we would subtract these terms from both sides, and then divide both sides by negative 2bc, and we'd have the cos of A isolated, and that is the alternate form. So these are interchangeable, but they're set up here. The standard form is more useful when you want to solve for a side. Solve for a side. If you want to find side A, I'd use the first one here. If you want to find side B, the second one works, and side C, the third one works, because those are the sides that are isolated. Again, don't forget these terms are all squared. So when you do punch all this into your calculator and solve it, you're going to get a number that will have to be square rooted. The alternate form is useful when you are solving for an angle. These are good for the SSS condition. You pick an angle and you use one of these to solve for it. Angle A, angle B, or angle C. And don't forget, at the end you will have to use the cos inverse button to actually find the measure of that angle. The three sides of a triangle, the SSS condition, is what we're going to look at here in example 1. So here are the formulas. And let's see here. Okay, one word of caution too. When we're looking for our first angle, this will be the most important thing I say on this whole video. Solve for the biggest angle first. Solve for largest angle first. How do we know which angle is going to be the biggest? Well, it's across from the biggest side. Of all three sides of the triangle, 19 is the longest. Across from the longest side will be the largest angle. So we're going to solve for angle B. So I'm going to move this down here so we can just see this formula. We want to find angle B, so we're going to use the cos of B is equal to this stuff to find angle B. So the cos of angle B is equal to a fraction. In the numerator, our first term is a squared. In our problem, that's an 8, plus c squared. Our problem has c as 14, minus b squared, minus 19 squared. And we divide that by 2 times a times c, or 2 times 8 times 14. And if we punch all that into the calculator, we're going to get the cosine of b is equal to a decimal, negative 0.45089. Let's see, cosine is negative. I'm going to know right away that this is an obtuse angle. Because remember, here are the quadrants. Cosine is an x value. And if our angle is coming out here into the second quadrant, an obtuse angle, that makes these x values negative. So if cos of b is negative, we know right away it's going to be obtuse. And we punch into the calculator, we do the the cos inverse, we get angle B is approximately, go round off a little bit, 116.8 degrees. So here angle B is 116.8. Okay, once we get to this point, we could continue with the law of cosines. We could find angle A and angle C in a similar fashion with these alternate forms of the law of cosines. But usually it's easier to just do the law of sines now. Law of sines, remember, is just a simple proportion. We cross multiply, and it's usually easier to go that route. So let's find angle A next. If I wanted to do a law of sines proportion, I would start out with angle B inside B. 19 over the sine of 116.8 is equal to 8 over the sine of angle A. And if you do the computations, we cross multiply and divide. The sine of angle A is going to be a decimal, 0.37583. And of course we sine inverse that, and we get angle A's measure is approximately 22.1. So come back up to the picture. Angle A is 22.1. If we subtract the two angles that we have, A and B, from 180, we'll get angle C is about 41.1 degrees. 41.1 degrees. Now, when we did the law of sines and we started with one angle, remember we'd solve for the first angle that we were forced to, and then we would check to see if there was a second possible triangle with a different angle A. When you have all three sides of a triangle, side, 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 there is only going to be one solution. There's only one way to put those length sides together to form a triangle. The angles will fall into place, and there's only going to be one solution. So there's example 1. Do you see why it's wise to find the largest angle first in the example? If you know the cosine of an angle, you can determine if it is acute or obtuse. If cosine is positive, then our angle's between 0 and 90, and that means the largest angle is acute. If the largest angle is acute, then the other two angles will have to be less than that, and they're also going to be acute. If cosine is negative, like we found, then we know the angle that we're looking at is between 90 and 180, or an obtuse angle. If the largest angle is obtuse, then we're sure that the other two angles must be acute, because there can only be one obtuse angle per triangle. Example 2. Here is our other case. We have two sides and the angle between them, side angle side. So here they're kind of forcing us to solve for side A. Again, we can't do a law of sines proportion. We have one piece but not the piece across from it, sides and angles. So here they're telling us, we got to find side A. And this is where we'll use the standard form. Right here is our standard form. A squared equals all of this. So let's work on finding side A. And let me move this up. I'm going to need plenty of room here. So A squared is equal to B squared, or 9 squared, plus C squared, which is 12 squared, minus 2 times B times C times the cosine of the one angle we do know, 25 degrees. Be careful with the calculators. You might want to use grouping symbols for when we subtract this second term. 9 squared plus 12 squared equals minus left parenthesis. Do all this in there, close parenthesis, and then hit equals. And let's see, you're going to get A squared is approximately 29.2375, and then we square root, and you're going to get A is about 5.4. So A is 5.4. Now we have options. We have all three sides, and we have one angle. So the next question will be, do we solve for angle B next, or do we solve for angle C? And in each of these cases, we're going to have to look for a possible second triangle. Now here's the big picture. This is what's going to happen as we finish this example. We can first go after angle B. Once we do that, we can check for a second triangle. Maybe there will be a second triangle. And we'll have one triangle that works and the other one that will not work. And let's say, on the other hand, maybe we went for angle C first. If we solve for angle C first, we might check for another possible triangle, and there will be one. And then either one of them will be the good one, and the other one will be the bad one. The idea here is, no matter which angle we go after, B or C, we will get a triangle that works, and we will get another triangle that doesn't work. But some of these are a little different than what we've seen when we did the law of sines. So let's go first after angle B. Let's go angle B first. So if we go after angle B, we're going to set up a law of sines. So we have side A now is 5.4. So our law of sines would be 5.4 over the sine of 25 is equal to, and we're going after angle B, so 9 over the sine of angle B. And this works out to, angle B is going to be about 44.8 degrees. So here we'd look for a second triangle. I'm just going to come scratch one over here very crudely. This is ABC. The sides are still the same. Angle A was given at 25. And we found this angle B was 44.8. So our other angle B is going to be 135.2. And we can quickly find angle C. Angle C up here is going to be 19.8. And if we come back over to this triangle, angle B we found was 44.8. And if we subtract to find angle C, we get 110.2. Now look at that. It looks like we have two triangles that work. We started out with side angle side. We found angle B was 48. The second triangle had an angle B that was 135.2, and each of those was a triangle that had some degrees left over for angle C. So at first glance, it looks like we have two viable triangles, but one of them doesn't make sense. If we remember to check the feasibility, largest angle across from the largest side. Let's see, here in the triangle we have largest side is 12. And if we look across from it, that's definitely not the largest angle. Angle B is the largest angle. Across from the largest angle is not the smallest side, but the middle side. So this triangle does not make sense. It's a nonsense triangle. You could not put a triangle together in the real world with those length sides and those sized angles. But let's go back to our first one here. The 110 is the biggest angle. That is across from the biggest side. The 25 degrees is the smallest angle. That is across from the smallest side. So this is our triangle that worked. This is our solution. Now let's see if I have enough room to squeeze it in here. Clear some of this out. In this case, we went after angle B first. That's what we went after. So let's go back up to this triangle, our original, and I'm going to draw two of them down here, a little smaller, but they should work with just the given information and the first side that we found. These angles were 25. This side was 12, 9, 5.4, 12, 9, 5.4, and we went after angle B first in the last attempt. Now let's go after angle C first. So now we're going after angle C first. We had angle A was given. Now let's say we go after angle C. So I would set up a law of sines, proportion. 5.4 over the sine of 25 is equal to 12 over the sine of C. And if I went this route, I would get angle C is about 69.9. So here, let me switch to red, this angle C was 69.9. The other triangle, possible triangle, would have an angle C of 110.1. And then for the third angle here in the first triangle, I have an 85.1 degrees left over. In the second possible triangle, I have a 44.9. So again, we have two solutions that seem to work. But look, this triangle is almost identical to the good one we found in the first attempt. The angles are slightly different. Angle C up here was 110.2. Here it's 110.1. Angle B is 44.8. This angle B is 44.9. But these two are pretty darn close. Our first triangle here is a nonsense triangle. Here is our largest side 12. It is not across from the largest angle. So this one is nonsense. So to sum up, it doesn't matter which angle we went after first, we're going to get a nonsense triangle and a viable triangle. And these nonsense triangles are, different than what we saw with the law of sines. We could have a nonsense triangle where two of the angles were greater than 180. That's always a possibility too. So be a little more careful with the law of cosines. Remember, solve for the largest angle first when you're given a side condition. If you start out with side angle side, you do want to check for those second possible triangles. So here for the practice problems, number 5 is just side. Remember, largest first. Solve for that largest angle first, then go from there. In the team huddle number 7 here, you will find a second triangle, and then one of them will be nonsense, one of them will be good. You'll get one nonsense triangle if you go after angle C first. You will get a different nonsense triangle if you go after angle B first. But no matter which route you take, you will get the good answer, the good triangle. So stop the video, solve these practice problems, and then turn it back on and check your work. Alrighty, here, let's work on number 5. And of course we want to go for the largest first. Here side C is the biggest, so we're going to go after angle C. So we're going to use this alternate form of the law of cosines. So the cos of C is equal to a squared plus b squared minus c squared, all divided by 2 times a times b. And I got my trusty calculator right here. And let's do this numerator and denominator separate. So we have 10 squared plus 12 squared minus 16 squared. And we get equals, this numerator is negative 12. And the denominator is 240. So we want to do negative 12 240 and cos inverse that. So there's our negative 12 divided by 240 equals half. And then we cos inverse. Inverse cos, 92 point, let's round that off to one decimal place, 92.9. So angle C is 92.9. Alright, now it's a piece of cake. Now we can just do a law of cosines, or a law of sines, excuse me. So we have 16 over the sine of 92.9, and let's go after angle A. 10 over the sine of A. So the sine of A is going to equal 10 times the sine of 92.9 divided by 16. So let's see here, clear that out. We got our 92.9, and we want the sine of that, and then times 10, and that's our numerator, and we want to divide that by 16. There's our decimal, and now we want a sine inverse. Inverse sine, and we get 38.6. So angle A is 38.6, and we find the missing angle by 180 minus our 38.6 minus the 92.9, and we got our missing angle, a B of 48.5. 48.5 degrees. All sides were given, all angles have been found, the triangle has been solved. Okay, and what I might do here, let's clear all this out because we might as well go through both possible solutions here. So here's our starting triangle, and let's see here. We're going after side A. We have to find side A first. So a squared is equal to b squared plus c squared minus 2b c cos of our angle A, which is 30. And we punch all this into the calculator, and then when that number pops up, we square root it to get just plain old A, and we get A is 18.6. So I'm going to come back up to the picture. A is 18.6. Again, now we have options. We can solve for angle C, and we'll get a good triangle and a triangle that doesn't work. Or we could try to solve for angle B. We'll get a different triangle that did not work, or we can also get the triangle that does work. And we no longer need the law of cosines here, since will be law of sines for here on out. So let's see if we can squeeze all this in here. Let's go angle B first. Angle B first. And let me draw two triangles. This is just the given stuff that we have. 30, 15, another 30, 18.6. Let's see here. That'll be good enough to get us started. So we're going after angle B. So we set up our law of sines. 18.6 over the sine of 30 is equal to 15 over the sine of B. And if we go that way, we get a B of 23.8. 23.8. And let me get this out of the way there. So there's that triangle with a 23.8 angle B. And I'm going to have another triangle, our second possible. So all the given stuff I'm filling in. 18.6. If this angle B was 23.8, we subtract that from 180 and get a different angle B. This angle B is 156.2. Now this is a little different than the one we did before, because now we have a triangle that will not work at all, because we have two angles, and those two angles alone are greater than 180. So this is not a triangle, or not possible at all. It's not just a triangle that doesn't make sense. It's not going to be a triangle even to begin with. Because if we looked for the missing angle, we would be at negative 6.2 degrees, and there's no such thing in a triangle. And in the other solution, we had a 126.2. Now let's see, we have our biggest angle here, biggest side is across from it, smallest angle is B, across from that is the smallest side. So this one works, smiley face. This one didn't work, didn't make sense at all. Now let's say when you were doing your practice problem, maybe you didn't go for angle B first, maybe you went for angle C first. And this will lead us down a different path. One of the turns will take us to the good triangle, the other turn will take us to another nonsense triangle. So if we go after angle C, let's see here, we're going to need two triangles. Let's see, ABC, 18.6, 30, this is 15. The one angle we were given was 30. And let's see if I can just do this. Oop, oop. There we go. Copy that. And I can, oh, I missed it. Try it again. Okay, copy, paste. There we go. So here we're going after angle C first. And I'll set up my proportion. 18.6 over the sine of 30 is equal to 30 over the sine of angle C. And if we go this route, we get angle C is about 53.8. So this angle C was 53.8. If we subtract that from 180, we get our other possible angle C, which is 126.2. And now we got these two angles, so the third angle is going to be 23.8. And back up to the first triangle, we have enough degrees left over for this angle B, and this angle B is 96.2. So we do have two triangles that seem to work mathematically, but one of them is geometrically impossible. Let's see here. Here's our biggest side, 30. Across from the biggest side is not the biggest angle. Biggest angle is 96.2. And across from that biggest angle is actually the shortest side. So this triangle is our nonsense. It seems to look good, S-E-N-S, but it doesn't geometrically make sense. And this triangle does seem to work, and it just so happens to turn out to be this is the same triangle. Angle C is 126.2, angle B is 23.8, and the sides are all matching up. So no matter which route you took, angle B first or angle C first, you will get the right triangle, and you're going to get some other nonsense triangle, either one that is completely impossible or one that is geometrically impossible. The assignment for this section, page 611, 1, 4, 5, and 9. And when you are doing a side angle side case, you don't have to completely solve for both nonsense triangles. Just pick a route, go for the first angle that you want to, and then find a nonsense triangle, find the good triangle, and that's all I'm interested in, is that the correct solution. So give those 4 problems a shot.